In recent assessments, the so-called invincible Russian S-400 air defense missile system is under scrutiny for its actual combat performance. Reports from the Ukrainian theater have drawn attention to the vulnerabilities of the S-400. During the nights of April 16th to 17th, Ukrainian forces reportedly employed ATACMS tactical missiles launched from HIMARS systems to precisely strike S-400 installations at the Kherson military airport in Crimea. Satellite imagery reveals significant damage to key S-400 components, including launchers, radars, and monitoring equipment, prompting doubts about the system's effectiveness in real combat scenarios. Only a few days later, on April 23rd, Ukrainian forces again targeted the S-400, this time hitting a Russian radar system with 3 GMLRS missiles launched from HIMARS system, known for its limited range and firepower, exposed the fragility of the S-400. These incidents raise questions about the S-400's efficacy as an air defense asset. On August 23 last year, the S-400 system, worth hundreds of millions of dollars, was destroyed by Ukraine's Neptune anti-ship missile in Crimea. The so-called invulnerable S-400 was actually unable to stop even a subsonic missile. Similar issues have been observed in other theaters of conflict. In February 2020, Turkey deployed the S-400 in Idlib, Syria, intending to protect its forces stationed there. However, when Syrian missiles and artillery targeted Turkish positions, the S-400 failed to provide effective protection, resulting in over 30 Turkish casualties. Additionally, Israeli F-35 stealth aircraft have reportedly conducted strikes on Syrian and Iranian targets with impunity, further undermining confidence in S-400's capabilities. In April 2018, during joint airstrikes by the US, UK, and France against Syria, despite claims of intercepting 71 cruise missiles with the S-400, the targets reportedly suffered varying degrees of damage, casting doubt on the system's actual interception capabilities. Similarly, in September of the same year, Israeli F-16s breached the S-400 defense line in Syria, striking weapons depots at Damascus International Airport without encountering effective resistance. The Libyan civil war in 2020 further underscored the S-400's limitations. Turkish-made armed drones operated by the Government of National Accord inflicted significant casualties on forces protected by the S-400, revealing its inability to counter modern aerial threats effectively. These instances expose the S-400's facade. The root cause lies in systemic issues within Russia's military-industrial complex. Russia's pursuit of short-term political gains has led to a lack of long-term planning and systemic consideration in weapons development. While focusing on technical specifications, they have overlooked the complexity of real combat environments, resulting in repeated failures of equipment in actual warfare. In contrast, the Patriot system of the United States has demonstrated consistent performance in combat situations. During the Yemeni civil war, Patriot systems successfully intercepted most of the ballistic missiles launched by the Houthi forces, targeting Saudi Arabia and the UAE. In January 2021, when Houthi forces launched ballistic missiles at Riyadh, the Patriot system intercepted them before they could launch their targets, averting a potential crisis. In the Ukrainian theater, facing frequent use of precision missiles by Russian forces, Patriot units stationed in Kiev and elsewhere have successfully intercepted such threats, showcasing their superior anti-missile capabilities. In response to escalating tensions, Russian President Vladimir Putin ordered the launch of the indestructible Zircon hypersonic missile and Kinjal hypersonic missile, intending to deliver devastating blows to Ukraine. Once again, the American-made Patriot air defense missile systems deployed in Ukraine have demonstrated extraordinary strength. With flexible tactical deployment and advanced electronic warfare capabilities, the Patriot system accurately detects and intercepts targets in complex electromagnetic environments. From May of last year to present, the Patriot system has intercepted Kinjal missiles on multiple occasions and even intercepted Zircon missiles this year. The lore of Russia's hypersonic weapons, whether the indestructible Zircon missile or the unstoppable Kinjal missile, has been shattered by the Patriot system. The United States' leading anti-aircraft and anti-missile technology is truly impressive. Putin's aspirations to reverse the tide of war with his ace in the hole remains unfulfilled. These instances vividly illustrate the disparity between the theoretical data and actual combat performance. despite claims from Russia and Chinese experts asserting the interceptability of the Kinzhal hypersonic missile, with terminal velocities reaching up to Mach 10. The Patriot system has successfully intercepted it in real combat scenarios. This serves as a reminder that while certain Russian and Chinese weapons boast impressive performance metrics on paper, shortcomings and limitations may be glaringly apparent in actual combat environments. The S-400 air defense system faces similar challenges. Despite being touted as one of the world's most advanced air defense weapons, there exists a considerable gap between its advertised superlative capabilities and its actual combat effectiveness, especially in its capability to counter stealth aircraft. While the S-400 claims the ability to detect stealth aircraft, the distance at which it can effectively lock onto and launch missiles at targets is limited. American aircraft, on the other hand, can use anti-radiation missiles to strike S-400 radars from greater distances. Therefore, the S-400's effectiveness against stealth aircraft in real combat situations is limited, dependent on both sides' electronic warfare capabilities and the standoff range of advanced weapons. The S-400 air defense system comprises 2 low-frequency arrays and 1 high-frequency array. Low-frequency radars are responsible for detecting and tracking stealth aircraft, but do not provide precise target information for targeting. High-frequency radars can only capture targets when stealth aircraft are relatively close, but once detected, they can provide weapon locks. The operational concept of the S-400 involves initially detecting the approximate location of stealth aircraft using low-frequency radar, and then using high-frequency radar to precisely locate the target, aiming to achieve a rapid lock-on as stealth aircraft enter the high-frequency radar detection range. However, Russia's claim that the S-400 radar can detect the F-117 stealth aircraft at a distance of up to 350 kilometers without interference and around 72 kilometers when facing interference appears overly optimistic. The radar cross-section of the F-117 is approximately 30 times larger than that of the F-22 and falls between the F-22 and the F-35. Independent expert analysis suggests that the Nebo-M radar array of the S-400 may only obtain sufficiently accurate target information for targeting the F-35 within a range of 32 kilometers. However, advanced American anti-radiation missiles like the AAR-GMER, with a range exceeding 96 kilometers, can destroy S-400 radars before the S-400 locks onto the F-35. Thus, while the S-400 claims the ability to detect stealth aircraft, the distance at which it can effectively lock onto targets and launch missiles is limited. American stealth aircraft and anti-radiation weapons can pose a threat to the S-400 from greater distances. In addition to limitations in countering stealth aircraft, the S-400 also faces challenges in dealing with low-altitude targets, particularly cruise missiles. When a large number of cruise missiles fly close to the ground, by the time the S-400 radar can lock onto them, too many missiles have already approached, making it difficult to intercept all of them even if detected in time. Compared to its shortcomings in short-range defense capabilities, doubts also surround the S-400's long-range interception capability. Reports indicate that the 40N6 long-range missile of the S-400, with a claimed range of up to 400 kilometers, has yet to be fully equipped. Despite Russia's announcement in 2013 to equip this missile, several years have passed, and the S-400 systems in Syria still use the 48N6 missiles with a range of 200 kilometers. Russia itself has not equipped this missile. It also raises doubts about its long-range interception capabilities. The 40N6 missile, designed to intercept high-altitude aircraft with low maneuverability, such as E-3 AWACS, E-8 ground surveillance, and RC-135 electronic reconnaissance aircraft, presents challenges due to its considerable size. Each S-400 launcher vehicle can only carry 2 of these missiles, as opposed to the 4 standard interceptors. The delayed deployment of this missile type may be attributed to technical challenges encountered during its development process, such as material technology and aerodynamic design. Russia has likened the S-400 to a combination of the Patriot and standard air defense systems. However, the short-range intercept missile 9M96 is merely an upgraded version of the Soviet-era S-300, with performance comparable to early versions of the Patriot. As for the area of anti-missile and anti-satellite defense, whether the bulky 40N6 missile can achieve high-altitude interception remains uncertain. In contrast, the American Standard 3 interceptor has already demonstrated satellite interception from maritime platforms, highlighting the considerable technological gap between the two systems. In response to this situation, Russia has focused on promoting the extended range of the 48N6 missile equipped with the S-400, positioning it as a competitive advantage in the market. Looking at the radar of the S-400, it still employs phased array elements from the last century, making it a low-end product by today's standards. Algorithms and signal processing are even more challenging. Without decades of technical accumulation, the S-400 radar may experience screen freezing during operation. The firepower battery of the S-400 is equipped with multiple radars, each with its own function, boasting a detection range of up to 600 kilometers, although its effective operational range is approximately 400 kilometers, providing a 360-degree coverage. In comparison, the American Patriot system's firepower battery has only one AN/MPQ-65 radar, with a detection range limited to within 170 kilometers for aircraft and 100 kilometers for ballistic missiles. In terms of performance parameters, the S-400 seems to have the upper hand. In particular, the medium-range 48N6 missile has a range of 200 kilometers, surpassing the maximum range of the Patriot II, which is only 160 kilometers, with the Patriot 3 interceptor missile having an even shorter range of only 35 kilometers. This difference indeed suggests that the Patriot's performance may be lacking. However, actual combat performance is the true test. The tracking radar of the S-400 struggles to continuously track targets beyond 60 kilometers, especially stealth aircraft. In contrast, the Patriot system, with its phased array radar technology allowing flexible scheduling and frequency agility, demonstrates more stable detection and tracking capabilities in complex electromagnetic environments. In stark contrast to the S-400's frequent setbacks in actual combat, Taiwan's air defense missile systems, supported vigorously by the United States, are showcasing increasingly formidable capabilities. Not only does the U.S. sell advanced Patriot air defense missiles to Taiwan, but it also provides extensive technical support. Taiwan is also involved in the development of the American Standard series of anti-missile weapons. Moreover, Taiwan's own manufacturing capabilities are evidently superior to those of Russia and China. However, even with such favorable conditions, Taiwan's indigenous Skybow air defense missile, inspired by the Patriot, struggles to match the precision of the Patriot II, let alone the Patriot III. This demonstrates that even with hands-on guidance from the United States, fully replicating its cutting-edge air defense missile technology is no easy feat. The critical materials, processes, and algorithms involved are not easily imitated. In the 1990s, after importing the S-300 PMU-1 air defense missile system from Russia, China learned its cold launch technology and integrated storage and launch tube design to improve the Hongqi-9. The Hongqi-9 can be considered a weapon that amalgamates the air defense technologies of the United States and the Soviet Union. However, during its development process, China did not receive direct technical support from either the United States or Russia. Coupled with limitations in China's own industrial base, its performance is destined to fall short of the original Patriot or S-300 PMU. In contrast to Taiwan, China's foundation for replicating American weaponry is considerably weaker. Take the Hongqi-9 missile, for example. Although dubbed as China's Patriot, it mainly relied on obtaining a sample of a Patriot missile from the 1980s through Israel during its developmental process, rather than receiving direct technical assistance and support for the latest models from the United States, as Taiwan did. In this scenario, Chinese engineers could only engage in reverse engineering of the Patriot on a limited basis, combined with some of their own experiences in active radar guidance, to eventually develop the Hongqi-9 missile. Its radar and fire control systems primarily reference the Patriot's MPQ-53 radar. The Chinese Air Force has evidently recognized the gap between its air defense weaponry and that of the United States. Since the 1990s, China has heavily imported Russian-made S-300 systems, and in 2014, it spent $3 billion to purchase 6 battalions of S-400 systems, intending to rely on these Russian-made equipment to serve as the main force of China's air defense system for a considerable period. It intended to compensate for the deficiencies of domestically produced equipment. However, the Ukrainian battlefield has fully exposed many problems with the S-400 in actual combat, especially its vulnerability when facing American-made weapons. In contrast, with strong support from the United States, Taiwan's missile capabilities have continuously improved, enabling it to conduct precise strikes in the surrounding region. Taiwan has already mass-produced the supersonic anti-ship cruise missile Xiongfeng-3 with a range of 300 kilometers, and is developing the Xiongfeng-4 missile with a range of 1,500 kilometers and the Yunfeng cruise missile with a range of 1,200 kilometers. Compared to Ukraine's Neptune anti-ship missile, which falls short in both range and speed, the S-400 still helpless against its attacks, unable to detect or intercept them effectively. It can be inferred that when Taiwan's Xiongfeng-3 missiles and even newer models are deployed in combat, how will the Hongqi series missiles that mimic the S-400 withstand them? It will likely be even more challenging than the situation faced by the S-400 on the Ukrainian battlefield. This illustrates that even Taiwan, with close ties to the United States and direct technical support, still has a considerable gap in equipment level compared to the US military, let alone China, which primarily relies on simple imitation of American and Russian weaponry. Faced with Taiwan's increasingly powerful missile capabilities, it is likely to be difficult for the Chinese Air Force to find effective countermeasures. China's over-reliance on imitating Russian and American weaponry reflects a lack of originality. While there has been progress in manufacturing and technology, there are still deficiencies in top-level design and system integration. This stems from China's lack of independent research and development capabilities, let alone strategic thinking. In contrast, American weapon development emphasizes operational requirements and the enhancement of overall combat effectiveness through system interoperability. Every detail is carefully designed and validated to serve the improvement of overall combat effectiveness. This demonstrates America's leadership in military innovation and strategic thinking. Furthermore, the United States values learning from global hotspots to continuously improve weapon performance. In contrast, China and Russia are prone to self-congratulation and turn a blind eye to problems. This difference is reflected in equipment quality and adaptability. In the field of air defense and missile defense, the United States maintains a leading position worldwide, leveraging advanced military concepts, well-developed system architectures, and a high-quality technological foundation. While Russia may boast about certain data indicators, its weapons and equipment frequently falter in actual combat due to various shortcomings in its military-industrial complex. China mainly relies on imitation of Russia and American weaponry, lacking independent innovation capabilities. Faced with increasingly severe challenges, it is unlikely that China and Russia will have the strength to match that of the United States. Those who still advocate that Chinese or Russian air defense weaponry has surpassed that of the United States are either ill-informed or have ulterior motives.